Hey everyone, and welcome to this explainer. Today, we're diving into something absolutely fascinating, nature's balancing act. We're going to be looking at stability, succession, and human impact. Think of natural environments as these incredibly complex, self-regulating machines. We'll explore exactly how they work and, well, what happens when that delicate balance is completely thrown off. To get us started, I want you to just pause and think about this for a second. How is it that a forest can survive a totally devastating wildfire, literally bouncing back stronger than ever, but it struggles and honestly often fails to survive us, human interference? Today, we're going to unpack this exact tension between nature's built-in resilience and human disruption. And by the end of this explainer, you are going to see exactly how the mechanics of nature actually operate under the hood. So, to understand how an ecosystem survives something like a massive fire, we first need to define what we mean by ecological stability. Simply put, this is an ecosystem's ability to maintain its structure, its specific plants and animals, and its functions, like energy flow, over a really long period of time, even when disturbances hit. Think of it kind of like a healthy human body. If you go for a tough, stressful run, your heart rate and blood pressure, they spike. But once you stop, your body quickly self-corrects and returns to normal. A stable ecosystem does the exact same thing. It just bounces right back after a major stress event, like a severe storm or a long drought. Okay, let's dive into this. Stability isn't just, one magic trait. It's actually built on 5 distinct pillars. First up is carrying capacity. This is the absolute maximum number of individuals a system can sustainably support. Like, a specific patch of forest might only have enough food and space to support exactly 50 deer. Any more than that, and they literally start starving. Next is persistence, meaning a grassland just stays a grassland for centuries. It doesn't randomly decide to turn into a forest. Third is constancy, which keeps population sizes relatively steady year after year, completely avoiding those wild boom and bust cycles. And finally, we have resilience and resistance, which are honestly so crucial that they deserve a closer look. Now, there is a profound difference between resilience and resistance. Think of it like 2 totally different types of boxers. Resilience, that's how fast you recover after taking damage. It's the boxer who gets knocked flat on the mat but jumps right back up. In nature, this is like a coral reef regrowing after a bleaching event, or a grassland that catches fire but grows back almost instantly. Resistance, on the other hand, is the boxer who never gets knocked down in the first place. It's how well you avoid getting damaged entirely. Picture a cactus standing firm and surviving extreme desert heat without ever wilting. That's resistance. And all of these pillars work together to create something truly incredible: homeostasis. Basically, this is nature's internal thermostat. It's the self-regulating ability of an ecosystem to maintain total internal balance, even when the outside world is going completely crazy. Think about your bedroom. If it gets too hot, the AC kicks in to cool it down, right? If it gets too cold, the heater turns on. Well, nature is constantly running a massive planet-wide thermostat just like that. So, how does nature actually run that giant thermostat? Through feedback mechanisms. There are 2 main types, and they literally couldn't be more different from each other. Negative feedback is actually the healthy one. It's entirely self-correcting. If there are way too many deer, the wolf population naturally grows, they eat the deer numbers drop back down, and boom, balance is restored. It actively counteracts change. Positive feedback, however, that is a dangerous, self-amplifying spiral. Think of global warming. Warmer temperatures melt the ice, which means less sunlight is reflected away, so more heat gets absorbed by the Earth, which causes even more melting. Positive feedback doesn't stabilize things, it destabilizes, and it can easily lead to total collapse. And this brilliantly illustrates exactly how nature regulates itself. Nature powers these healthy negative feedback loops through some highly specific regulatory mechanisms. It's a finely tuned machine. Nutrients are perfectly recycled from dead leaves right back into living plants. Energy flows predictably from the sun to grass to the deer to the tiger. Populations are kept strictly in check by predators or even disease. And physical factors like the climate naturally select which species can even survive in an area to begin with. But if you interfere with this machinery, say by adding way too many fish to a small pond, they're going to eat all the plants, the oxygen levels will plummet, and that pond becomes a dead swamp. The precise machinery just breaks. So if that's how an ecosystem maintains itself once it's established, how does it actually grow in the first place? Well, that process is called ecological succession. If you were to leave an empty plot of land completely untouched for 100 years, it's not going to stay empty. You'll get weeds, and then grasses, then some shrubs, small trees, and eventually a fully mature forest. It is this gradual, highly predictable change in the types of species living in an area over time. Succession essentially has two different starting lines. Primary succession starts from absolute scratch. We are talking bare volcanic rock or land left behind by a retreating glacier. There is zero soil. And because soil literally has to be created from solid rock, this process takes thousands of years. Secondary succession, though, is much faster. That takes maybe a century or two simply because it starts from existing soil. This is what happens when a farmer abandons a wheat field or right after a forest burns down. The foundation, the soil, is already there waiting. Let's move to and see how this builds, step by step, from completely bare rock to a majestic forest. Step 1 features the pioneer species. These are incredibly hardy, tough organisms like lichens and mosses that can survive baking in the harsh sun and actually break down solid rock to create soil. Once there's enough soil, step 2 begins. Intermediate species, think fast-growing shrubs and pine trees, start to take over. And finally, we reach step 3, the climax community, which is dominated by large, slow-growing, highly stable trees. This climax community is really the ultimate goal. It is the final, completely stable stage of succession. At this point, the plants are making just enough food for themselves, meaning the production to respiration ratio perfectly equals 1. They are creating exactly as much energy as the system uses up. Nothing more, nothing less. You see incredibly high biodiversity here, with complex, deeply interconnected food webs. Nutrient cycling is perfectly balanced, literally nothing goes to waste. And because of all this harmony, it remains stable for decades or even centuries, boasting incredibly high resilience to minor natural disturbances. It really is nature at its absolute peak. But it's super important to note that a climax community isn't always some towering, leafy forest. Climate is the ultimate boss here. In a temperate zone, sure, the climax is a deciduous forest full of oaks and maples. But in drier areas, the absolute peak of ecological succession might be a sprawling prairie grassland, or even a harsh desert scrub filled with cacti. You absolutely cannot force a climax rainforest to grow in the middle of a desert environment. The climate dictates the endpoint. Now, what happens when these perfectly balanced climax communities are permanently degraded by human disturbance? Because, while ecosystems can often recover pretty well from a natural fire, human impacts are a completely different story. Take the Western Ghats in India, for example. Historically, this was a dense, highly diverse tropical rainforest. But after centuries of heavy deforestation for agriculture and massive tea plantations, vast sections of it haven't just bounced back. They've been permanently reduced to degraded scrub and open grasslands. Let's link this back to our earlier concepts to really see the mechanics of this destruction, because human activities systematically act as a wrecking ball to those 5 pillars of stability we talked about. Carrying capacity reduced because we're constantly shrinking the available habitat. Both resilience and resistance completely drop, meaning ecosystems recover way slower and fall victim to disease much, much faster. Persistence is completely lost as lush forests literally turn into dry grasslands, and constancy is just shattered, replacing those nice, stable populations with wild, unpredictable boom and bust cycles. So the crucial point is that this isn't just some theoretical math on a chalkboard. Look at this number, 22,000 square kilometers. That is the size of the completely oxygen-depleted dead zone in the Gulf of Mexico. This happens through a process called eutrophication. Basically, excess fertilizers from human agriculture wash down into the water, which triggers these massive, explosive algal blooms. When all that algae inevitably dies and decomposes, the process completely sucks all the oxygen right out of the water, creating a 22,000 square kilometer graveyard where absolutely no fish or marine life can survive. This is a massive, human-made, positive feedback loop in action. And urbanization acts much the same way on land. Over in Mumbai, a staggering 70% of their natural mangrove habitats have been completely lost. They've been paved over and replaced by concrete for urban development. When you directly remove a natural climax community like this, you don't just lose the pretty birds and the biodiversity. You lose the crucial ecosystem services they provided, and that directly leads to severe real-world consequences like massively increased urban flooding and dangerously hotter city temperatures. Everything we've looked at today really shows that nature is this exquisite, self-regulating machine, capable of incredible resilience against natural disturbances. But human activities are currently acting as the ultimate, dangerous, positive feedback loop, systematically dismantling nature's natural defenses. And since we completely, absolutely rely on these stable ecosystems for our own food, our water, and our survival, I want to leave you with this provocative thought. If we continue to push these ecosystems toward total collapse, how long is it until we exceed our very own carrying capacity? Thank you so much for joining me for this explainer, and I really hope this leaves you looking at the natural world and our place inside it in a whole new way.